Hello everyone, my name is Keshvi Santoki and today I'm going to discuss about the concepts of IF frequency and the choice of IF. So let's begin. In communication receivers, signals are received at very high ratio frequencies. Now the problem is processing high frequency signals directly is very difficult and unstable. So to solve this problem, receiver first convert the received signals into a fixed lower frequency, which we call the intermediate frequency or IF. This concept is mainly used in super heterodyne receivers, which are widely used in radios and televisions. Understanding the intermediate frequency. Intermediate frequency is a fixed frequency obtained after mixing the received signals with a local oscillator signal. The formula is very simple. IF is equal to received frequency minus local oscillator frequency. The main idea here is that instead of working with different high frequencies, we always work with one fixed frequency. This makes the receiver simple, stable, and reliable. Why IF is used? If we try to directly process the high frequency signal, then filtering becomes difficult, amplification becomes unstable. So, IF is used to solve this type of problems. Using a fixed IF helps in easy filtering, stable amplification, better overall receiver performance. Problem with high frequency signals. High frequency signals are very sensitive. Even a small change can cause distortion, instability, and poor selectivity. Designing the circuits for such high speed frequencies is complex and expensive. Benefits of using IF is filtering become easier because the filter can be designed for one frequency. Amplification becomes stable because gain remains constant. Receiver performance improves with better selectivity and sensitivity. Frequency conversion process. So let's take one example for that, like received frequency is of 1000 kilohertz and the local oscillator frequency is 1455 kilohertz. Using the formula we discussed and putting that value using the same IF in all receivers make design easier and more reliable. Now now we are going to discuss the advantages of using IF. Better selectivity means nearby channels can be separated easily, improved noise performance, giving clearer output, stable amplification with the less distortion, easy and accurate filtering, universal usage in radios and TVs. That is why almost all modern receivers use IF. Choice of IF frequency. Choosing IF is always a trade-off. If 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 should not be too high or too low. The choice depends on the image frequency rejection, filter design, and overall receiver performance. Image frequency. One of the important concept related to IF is image frequency. Image frequency is an unwanted frequency that produces the same IF as the desired signal. The formula for this is image frequency is equal to signal frequency plus or minus 2 into IF. If the image frequency is not removed, it causes interference. What are the effects of the IF? So, if the IF is high, the image frequency moves far away, which is easier to remove using filters. If IF is low, the image frequency comes closer, which is difficult to filter. So, IF must be chosen carefully to avoid image interference. And now we are going to discuss the significance of IF. Intermediate frequency is very important concept in communication receivers. It as it provides receiver stability, improved selectivity, better sensitivity. Choosing the right IF is always a balance, as high enough to reduce image interference, low enough to allow easy filtering and simple circuit design. Because of this balanced communication system, it becomes efficient, reliable, and high performing. So, finally, from this, I can say that IF simplifies receiver design, improves performance, and it is used in almost every modern receivers. That's all about the intermediate frequency and the choice of IF. Thank you for listening.